A crack over 100 miles long tears through the Antarctic ice sheet like a scar across the Earth. That's the distance from Los Angeles to San Diego, and at its widest, it's broader than the Hudson River. You could fit all of Manhattan inside it and still have ice to spare. And behind that crack, there's something even more terrifying. The Doomsday Glacier. This massive river of ice, officially called Thwaites, is already melting from underneath. Thwaites isn't just any glacier, it's the cork in a bottle, the keystone holding back the entire West Antarctic ice sheet. When it goes, it will trigger a domino effect that releases ice equivalent to the entire state of Mexico, melted and poured into our oceans. So, why is Antarctica coming apart? Let's dive into the forces at work beneath the ice and uncover what's driving these massive cracks, and why this matters to all of us. Two invisible killers, heat from above and heat from below. The atmosphere warms, summer temperatures rise. Melt ponds form on ice shelves that have been frozen for millennia. Water finds cracks. Water expands those cracks. Water destroys. Scientists have a term for this: hydrofracturing. The ice doesn't just melt, it tears itself apart. But that's only half the story. Beneath the ice, the ocean burns. Not with fire, but with heat. Warm currents, degrees warmer than they should be, gnaw at glacier bases, eating away at foundations that have stood since before humans walked upright. Think of an ice shelf as a dam. Now imagine that dam being attacked from the sky by rain and from below by acid. How long before it fails? In West Antarctica, we're finding out. The Thwaites Glacier, the one scientists call the Doomsday Glacier, perfectly illustrates this terrifying process. Roughly the size of Britain, it sits on bedrock that's actually below sea level, which is essentially a fatal design flaw. Once warm ocean water sneaks underneath and starts melting it from below, there's no natural barrier to stop the process from spiraling out of control. That acceleration is already happening in a big way. Thwaites Glacier is now moving toward the ocean 70% faster than just a few years ago. Scientists who once thought it might stay stable for another decade now say it's like watching the final act of a disaster unfold in real time. When Thwaites Glacier finally collapses, and all the evidence says it's not a matter of if, but when, it alone will cause around 3 meters, 10 feet of global sea level rise. That's water covering every coastline on Earth by 10 feet. But Thwaites is really just the cork in a much bigger bottle. This glacier acts like a natural dam holding back a massive chunk of the West Antarctic ice sheet. Once it's gone, the entire ice sheet will begin its unstoppable slide into the ocean. That's enough ice to raise sea levels by an additional 12 feet. Combined, we could see over 20 feet of sea level rise from West Antarctica alone. And there's growing evidence that parts of East Antarctica, long thought stable, are starting to show signs of instability too. The terrifying reality? Once this tipping point is passed, no force on Earth can stop it. You can't build a wall strong enough to hold back a collapsing ice sheet. You can't negotiate with physics. And once it starts, the process can't be reversed. We would be locked into centuries of rising seas, no matter what we do with emissions from that point forward. Let me put this in terms that hit close to home, even thousands of miles from Antarctica. In New York City, home to 8 million people, Hurricane Sandy in 2012 showed us what severe flooding looks like. The storm surge flooded lower Manhattan, shut down subways, and killed dozens. But Sandy was rare. With just 3 feet of permanent sea level rise, that flooding would happen with every high tide and storm, making much of the city unlivable. In Bangladesh, already struggling with poverty and instability, 32 million people will face direct threats from rising seas by 2100 if trends continue. Most of the land is barely above sea level, and farmers are seeing salty soil and contaminated freshwater wells. Millions are already becoming climate refugees, forced to flee to crowded cities or abroad. And Bangladesh is not alone. Across the globe, other low-lying nations are staring down the same fate. The Maldives is a stark warning. This island nation of 540,000 people averages just 1 meter above sea level. Climate projections say 1.5 feet of sea level rise would submerge 77% of the country, effectively wiping it off the map within the lifetimes of today's generation. Even wealthy, advanced countries aren't safe. The Netherlands has defended its coastline for over a millennium with top-tier defenses. Approximately 1/3 of the country lies below sea level, protected by dikes and pumps. Still, Dutch experts admit limits. 1 meter of rise is manageable, 2 meters very difficult, and 3 meters catastrophic. The scale is staggering. The UN estimates around 900 million people, about 1 in 10 worldwide, live in low-lying coastal areas at risk from rising seas. All of them are directly tied to what happens to Antarctica's ice in the coming decades. The direct impact of rising seas is just the start of a much larger crisis. Displacing hundreds of millions from coastal areas triggers a cascade of problems that could destabilize entire regions and the global economy. We're already witnessing early climate-driven mass migrations. Island nations like Tuvalu, Kiribati, and the Marshall Islands are sinking, with governments negotiating to relocate their populations. Now imagine this happening to major cities with tens of millions of residents. Political and social upheaval would be inevitable. Freshwater contamination is another looming disaster. As seawater pushes inland, it seeps underground, polluting aquifers that cities depend on. Places from Miami to Mumbai are already battling saltwater intrusion, a problem set to worsen as seas rise. What makes this situation even more frustrating is that we were warned about it decades ago. In 1978, glaciologist John Mercer published a paper cautioning that human-driven global warming could destabilize the West Antarctic ice sheet, triggering catastrophic sea level rise. Back then, most dismissed his warnings as speculative or alarmist. Now, nearly 45 years later, Mercer's predictions are unfolding before our eyes. Global temperatures have risen 1.2 degrees above pre-industrial levels. Warm ocean waters are infiltrating deep beneath West Antarctic glaciers, and the ice sheet shows unmistakable signs of instability. We had almost half a century to act on these warnings, but instead, much of that time was lost debating whether climate change was even real. The Antarctic ice sheet has been relatively stable for 34 million years, serving as Earth's primary climate regulation system. Now, within the span of a few decades, we've managed to destabilize this ancient system and set in motion changes that will reshape every coastline on the planet. We can't stop all sea level rise at this point. Some is already locked in by the emissions we've already put into the atmosphere, but we can still choose between manageable change and complete catastrophe. We can decide how many cities get submerged, how many nations disappear, and how many people become climate refugees. That choice is being made right now, today, with every policy decision, every election, every dollar that gets invested in clean energy instead of fossil fuel infrastructure. The crack in Antarctica isn't just in the ice, it's in time itself. And through that crack, the future is leaking out. Despite how dire this situation sounds, it's crucial to understand that we still have some control over how this story ends. The difference between 50 centimeters of sea level rise and 150 centimeters by 2100 is enormous in terms of human impact. The lower end of that range represents a manageable challenge that humanity can adapt to, while the higher end represents a civilizational crisis that could destabilize the entire global order. What determines where we end up on that spectrum is largely determined by the choices we make right now. How quickly we transition away from fossil fuels, how seriously governments take climate adaptation planning, how much we invest in protecting vulnerable communities, and how effectively we can cooperate internationally on this challenge. We actually have most of the technology we need to address this crisis. Clean energy is now cheaper than fossil fuels in most markets. We have proven methods for capturing carbon from the atmosphere. We know how to build resilient infrastructure and restore coastal ecosystems. And we have successful examples of managed retreat from vulnerable areas. What we're missing isn't technology. It's political will and a sense of urgency proportional to the threat we're facing. Every year we delay serious action makes the eventual transition more expensive and more disruptive. Every ton of carbon dioxide we emit into the atmosphere is essentially a vote for higher sea levels and more climate chaos. Every crack that spreads through Antarctic ice is a message that we're running out of time to prevent the worst-case scenarios from becoming reality. But here's what gives me hope amid all this doom. Humans are incredibly good at solving problems once we decide to take them seriously. We've done it before, and we can do it again. Take the ozone hole crisis in the 1980s. Scientists discovered that chemicals called CFCs were destroying the protective ozone layer above Antarctica. The hole was growing every year, threatening a global surge in skin cancer and ecosystem collapse. Yet, instead of decades of debate, the world came together and banned CFCs through the Montreal Protocol in 1987. Today, the ozone hole is healing and expected to fully recover by 2066. We literally fixed a planetary crisis through international cooperation and innovation. The COVID-19 pandemic, despite its tragedy, also showed what humanity can do when pushed. We developed multiple effective vaccines in less than a year, a process that usually takes a decade. We transformed entire economies almost overnight. When faced with an existential threat, we proved we can move faster than anyone thought possible. The climate crisis moves more slowly than a pandemic, but the stakes are far higher, and the solutions demand the same kind of coordinated global response. Right now, we're witnessing the fastest energy transition in human history. Solar power is now the cheapest electricity ever produced. Electric vehicles went from a niche curiosity to 14% of global car sales in less than a decade. Countries like Costa Rica run nearly 100% on renewable energy. China, despite being the world's largest polluter, is installing more clean energy capacity than the rest of the world combined. These aren't small steps, they're revolutionary changes happening at breakneck speed. Solutions to protect ourselves from rising seas are advancing fast too. The Dutch have pioneered floating neighborhoods that rise and fall with the tides. Singapore built underground freshwater storage to supply the city during emergencies. Bangladesh developed floating gardens that grow food even during floods. Miami Beach installed a $500 million pump system that's already reducing flood damage. These aren't desperate last-ditch efforts, they're working proof-of-concept projects showing how we can adapt to rising seas while fighting to slow them down. Even more exciting are the breakthrough technologies on the horizon. Direct air capture machines that pull carbon dioxide straight from the atmosphere are coming online in growing numbers. Scientists are developing enhanced weathering techniques that could remove gigatons of CO2 while making our oceans less acidic. Pilot projects for solar radiation management, essentially giving Earth temporary sunglasses, are being tested as a stopgap while we reduce emissions. Some of these technologies may sound like science fiction, but so did smartphones just 30 years ago. The generation coming of age today refuses to accept that this crisis is unsolvable. Greta Thunberg's school strike movement has evolved into a global political force, changing election outcomes worldwide. Young people are choosing careers based on climate impact, flooding into clean energy, climate law, and environmental engineering. Even the fossil fuel industry, with all its power and resources, struggles to recruit top talent because the brightest minds want to work on solutions, not problems. Investment in climate solutions is flooding in at an unprecedented scale. In 2023 alone, the world invested $1.8 trillion in clean energy, more than ever invested in fossil fuel infrastructure in a single year. Major banks are divesting from coal and oil projects. Insurance companies are refusing to cover fossil fuel developments because they're too risky. Economic momentum is shifting so fast that even oil executives privately acknowledge their industry's dominance is ending. What we're discovering is that most climate solutions actually make our lives better, not worse. Cities with extensive public transit are more livable and economically vibrant. Energy-efficient buildings are more comfortable and healthier. Countries investing in renewable energy gain more energy security and create more jobs. The clean energy transition isn't a sacrifice, it's an upgrade. And perhaps most importantly, every success story creates momentum for the next. Every wind farm built makes the next cheaper and easier to approve. Every electric vehicle on the road expands the viability of charging infrastructure for all. Every city that adapts to climate impacts provides a roadmap for others facing similar challenges. Success breeds success. And that positive feedback loop is accelerating. For too long, climate change felt abstract and distant. Now, it's literally written in ice, visible from space, impossible to ignore. Sometimes it takes a crisis to unlock human potential, and we may be approaching that moment right now. We always imagined climate change would come with fire and extreme heat, but it turns out the end of the world as we know it might begin with something quieter, more deceptive, the sound of ice breaking. Subscribe for more climate investigations and share this video. The more people who understand what's really happening, the better chance we have to change course before it's too late.